Imagine this, a calm blue planet slowly rotating in the void, clouds drifting lazily over vast oceans, and then, somewhere deep in the cosmos, something awakens, something invisible, relentless, ancient. It emits no light, makes no sound, yet its pull is stronger than fate itself. And in that moment, Earth begins to fall into an abyss with no return. At first, no one notices anything. Everything is happening too far away, too quietly. A black hole, an object that emits no light, remains invisible even to the most powerful telescopes. But its presence reveals itself through gravitational distortions. Stars begin to shift ever so slightly, their light bending as if the very fabric of space has turned soft and pliable. This is the first whisper of catastrophe. If Earth were suddenly brought close to a massive black hole, everything would begin with gravity. Not a sudden blow, not a flash, but a slow, inexorable change. Imagine standing on the surface of the planet and suddenly feeling that your weight has increased just a little, a few percent, then more and more. This is not falling in the usual sense. It is a gradual acceleration, as if reality itself is pulling you forward. But Earth is not a stone, not a monolith. It is a complex system where everything is connected: the atmosphere, the oceans, the lithosphere, the core. And the black hole's gravity begins to literally stretch the planet. This phenomenon is known as tidal forces. They act in such a way that the side of Earth facing the black hole is pulled more strongly than the opposite side. At first, the oceans begin to behave strangely. Tides that on Earth usually rise just a few meters begin to grow, tens, then hundreds of meters high. Entire continents are swallowed by water. Waves rise higher than mountains. They do not crash against the shores, they erase them, wiping away the boundary between land and sea. Then comes the atmosphere. It begins to stretch, like a thin veil carried off by the wind into space. The sky changes color. At first, it becomes unnaturally bright due to the bending of light. Then it begins to darken. The sun no longer appears as a perfect circle. It warps, stretches, splits apart, creating strange, almost mystical illusions. And all of this is only the beginning. As Earth draws closer to the black hole, tidal forces intensify. The planet ceases to be a sphere. It elongates, transforming into a gigantic droplet. Imagine a world thousands of kilometers long, yet compressed along a narrow axis. Continents tear apart. Tectonic plates collide with monstrous force. Volcanoes erupt across the entire surface at once. The temperature rises, not from the sun, but from internal friction. Earth is literally being torn apart, releasing an enormous amount of energy. Everything that has ever lived vanishes within minutes. But the most terrifying part lies ahead. As Earth approaches the event horizon of the black hole, the boundary beyond which not even light can escape, a process begins that physicists call spaghettification. It sounds almost humorous, but in reality, it is one of the most horrifying phenomena in the universe. Gravity on the near side of the planet becomes so intense that it stretches matter into a long, thin strand. Imagine the entire Earth being pulled like dough, transforming into an endless stream of matter falling into the abyss. Mountains, oceans, cities, everything loses its form, becoming part of this cosmic patok. If a human were in space nearby at that moment, they would no longer see a planet, but a glowing, distorted stream, like a cosmic river, disappearing into black emptiness.
But there is another aspect that makes all of this truly terrifying: time. Black holes distort not only space, but the very flow of time itself. To an outside observer, everything falling into a black hole begins to slow down. Earth appears to freeze at the event horizon. The final moments of its existence stretch into infinity. From a distant perspective, Earth never actually crosses the event horizon. It just gets closer and closer, more and more slowly, fading away until it disappears completely. But for Earth itself, or what remains of it, things unfold differently. Within its own frame of reference, the fall continues. Matter crosses the event horizon and plunges toward the center of the black hole, the singularity, a point of infinite density and zero volume. What happens there, we do not know. Modern physics breaks down at such extremes. The laws that govern planets, stars, and galaxies cease to make sense. In the singularity, familiar concepts of space and time dissolve. It is not just a place, it is the boundary of our understanding. But the influence of a black hole does not end with Earth. If such a catastrophe occurred in our solar system, the consequences would be far greater. The black hole's gravity would begin to alter planetary orbits. Mars, Venus, Jupiter, all would feel its pull. Their paths would become unstable, stretched, chaotic. Some planets might be flung out of the system, cast into the cold depths of interstellar space. Others, on the contrary, would begin to fall inward, repeating Earth's fate. The Sun, even the Sun, would not remain untouched. If the black hole were massive enough, it could capture it as well. And then, instead of a bright star at the center of the system, there would be a dark, invisible object surrounded by a glowing accretion disk, a ring of superheated matter spinning at tremendous speeds. This disk would shine brighter than millions of suns. Its temperature would reach millions of degrees Celsius. It would be a hell, blazing in the darkness. And yet, black holes are not merely destroyers. They play a crucial role in the evolution of galaxies. At the center of nearly every galaxy lies a supermassive black hole. In the heart of the Milky Way, for example, there is an object with a mass of several million suns. And still, despite their destructive nature, black holes are not cosmic vacuum cleaners that simply suck everything in. If the Sun were suddenly replaced by a black hole of the same mass, Earth's orbit would barely change. We would continue to revolve as before, only in complete darkness. The danger arises only when you get too close. And that is what makes this thought experiment so captivating and so terrifying. It reveals just how fragile our planet truly is in the face of cosmic forces, how insignificant we are compared to the scale of the universe. And yet, there is something beautiful in that. Because despite all this power, despite black holes, supernovae, gamma-ray bursts, and endless voids, we are here. We exist. We are capable of observing, of understanding, of asking questions. We are part of this universe, the same matter, the same laws, the same forces. And perhaps that is the most astonishing thing of all. The next time you look up at the night sky, remember, somewhere out there in the darkness exist objects capable of consuming entire worlds, and yet they are also the key to understanding the nature of space, time, and reality itself. Thank you for taking this journey with us. If you enjoyed this video, give it a like, share your thoughts in the comments about which cosmic mysteries you'd like to explore next, and be sure to subscribe so you don't miss what's coming. Stay with us, and until next time.